Doc, the physics of sound and music, we're going to do a digital logic circuit, and we're going to use the inquiry arc model as our framework. This consists of inquire, apply, reflect, and communicate. Inquire means identify a question. 2, apply principles in addressing that question. 3, reflect on the question from different points of view to evaluate your answer. And 4, to communicate. Now, this circuit I'm going to analyze, and the question I'm going to ask is, I want to know what y is. And that's usually the question when you have a circuit. You want to find out what the output is when things are going in. So I ask this question to myself, what is y? And I'm going to ask 2 secondary questions, what's p and q, since they're intermediate steps. And to answer the question, we make the truth table. That gives us complete information as to what's going on for all the possible inputs. Now, when you have A and B, each one can be 0 or 1, so that's 2 times 2, 4 possibilities. And to keep track of them, I do the binary counting, 0, 0, 0, 1. In other words, A is 0, and I go to B and let it run through as 2 values. And then I make A 1 and let B run through as 2 values. This is binary counting. 0, 0 is decimal 0, 0, 1 is decimal 1, 1, 0 is decimal 2, and 1, 1 is decimal 3. So with the 0 case and the 3 cases, we have 4 possibilities. Now for P, we have an AND gate. When we apply to find the analysis, for our question, we need to have some definitions memorized. We need to know that's an AND gate. We need to know that's an inverter. And this is a NAND, and this is an OR. So what does the AND gate do? Well, it takes the inputs, and it gives you a 1 if both inputs are 1. So here, A would have to be 1, and A is not 1 in the first 2 cases, so immediately I can put down 0, 0 for P and not think anymore. For the P to be 1, I need A to be 1. Well, here A is 1 in both cases, but this has to be 1 here, and the inverter will flip the 0 to 1, so I need the 1, 0 case. That's going to be 1, and when B is 1 and gets flipped to 0, that's not going to get through. So there's my result for the P. And if we go on to Q next to fill in the Q box, Q is a NAND gate, which you can think of as an AND NOT. So whatever you get for AND and NOT, inverted. Well, AND is going to be true only if both A and B are true, which means for AND you would have 0, 0, 0, 1. When you do the NOT on that, you flip it and go 1, 1, 1, 0. And then for OR, if P is 1, we're good. If Q is 1, we're good. And if both P and Q are 1, we're still good. That's what OR means. So here I have a Q is 1. We're good. We're good. We're good. And here, 0. Now, another question you might ask here is, can you simplify this? And the answer is yes, because, see, this Y result is the same as the Q result. And you may recognize the Y result as being the NAND. Q is the NAND, so this is redundant to have all this up here. And if someone gave you this, say in a work environment, say, hey, we have this solution to a problem, you could say, hey, I get you an easier solution. What we have here is just one NAND gate does the job, and you don't need all this up in here. You don't need this OR. You just need the Q, since the Q here is equal to the Y. Now we move to the reflection stage and reflect on our answer. Is it correct? Now I'm going to do something here that may look a little scary at first. We have these symbols. We have P, we have Q and Y, and we have these A, B's and all this stuff. But this is not that hard. You can think of the AND gate as multiplication. Think about AND. When AND is going to give you a 1, you have to have the inputs to be 1. Well, if you multiply the inputs, 1 times 1 is 1. 1 times 0 is 0. 0 times 1 is 0, and 0 times 0 is 0. So simple multiplication takes care of the AND definition. When you have the OR, you can think of addition. If you have inputs are 0, 0 plus 0 is 0, and you don't have any of them being 1, so the OR condition is 0. If one of them is 1, then 0 plus 1 is 1, 1 plus 0 is 1, and you have Y is a 1. true. If both are 1, 1 plus 1, you have to remember that you can't exceed 1. So 1 plus 1 in this kind of analysis is equal to 1. So let's use this algebra to work this out, and this will give us confidence and a double check that our answer is correct. So we're going to remember that whenever you have an inverter, the notation is to put a bar over that letter. So B inverted is B bar. So this is B bar, this is A, and since A and B bar are going into an AND gate, I multiply them, A times B bar. Now Q, these here for the Q have A and B going into an and then not. We invert the answer. So A and B going into an and means you multiply A times B, and the not, the bar must go over everything. The final answer, if A times B gets knotted, so that not over the top. And then we have the Q. For Y, this is OR, so we add these two together. Now this is really very neat because it's a double check. Now watch this. If I want to check the A and the B logic, well, A is 0. 0 times anything is 0, so this part is 0. And here, 0 times anything is 0, but there's a bar over the top, so that will be a 1. So this first case gives a 1. Checks out. The next case, 0 and 1, well, 0 for A, 0 times anything is 0, so this is 0. 0 times anything is 0 with the bar makes it a 1. That's a 1. It checks out. Notice I don't have to go through all the details with B. If I get my answer quicker, I just simply arrive at it by the logic. So here, for example, this next one, 1 and 0, A is 1, and B bar would be a 1, so 1 times 1 is 1. I'm finished. I don't even have to look at this, because if I have a 1 plus anything, well, if it's plus 0, it's going to be 1, and if it's plus 1, it's 1 again. So this has to be a 1 over here. It checks out. Finally, A and B being 1 each, this is 1 times B bar, which is 0, so that we're dead here. We're 0. And here, 1 times 1 underneath the bar, 1 times 1 is 1, but then bar over the 1 gives us 0, and it checks out. So we have looked at this from a different point of view, very important in the reflection stage when we reflect on our answer, and it checks out. And we're ready to now, with confidence, communicate this, the last step, on an exam, or let's say homework problem, or at a presentation.